Hello everyone, my name is Sahib and I am pursuing my Bachelor of Science Honours in Data Science and Artificial Intelligence from Indian Institute of Technology, Guwahati, India. So in this video, I will present my term project 3 as part of the trimester 9 course curriculum. So the project title NutriSense AI, a nutritional analysis and food recommendation system. So we'll start with a brief introduction and then look at the problem context. Next, we will discuss the project deliverables and how it addresses the identified problem. We will then look at the overall system architecture, followed by the dataset and the tools for implementation. After that, I will explain the nutrition analysis component and then move on to the machine learning component and its evaluation. We will then have a quick walkthrough of the codebase and the application interface. Finally, we will interpret the results, discuss the observation and limitation, and conclude with the possible future enhancements. So, NutriSense AI is a nutrition intelligence application designed to help users understand the nutritional composition of their meals and identify potential nutritional gaps and cover those through a suggested meal plan. Now we discuss about the problem context. So many people don't actively track or care about their nutrition targets. They rarely check if their meals meet daily requirements for essential nutrients. Everyone knows what they're eating, but it's difficult to judge whether the overall meal is nutritionally balanced, as different items contribute different nutrients in varying amounts, and to find out which targets are achieved and which are left. And when those gaps are identified, the challenge becomes what should I add to fix it? So here we need a system which solves this problem. So now we talk about what the project delivers. So first we have food search functionality, which allows users to retrieve food and nutritional information from the database. And second, we have meal analysis, where users can construct a meal by selecting foods and specifying their quantities. Then the system calculates the nutrition score for the selected meal, which summarizes how well the meal meets the configured nutritional targets. Then it detects the deficiencies, which identify nutrients that fall below the defined thresholds, and then recommend the food, where the system looks for suitable foods based on the identified nutritional deficiencies. And finally, the system provides meal suggestion based on those recommendations. Now, this slide shows the overall architecture of the system. We start with the food dataset, which is cleaned and pre-processed. Then the processed data is stored in a SQLite database. The Fast API backend provides the API layer between the database and the application services. On top of this, we have the nutrition analysis and recommendation logic. These services process the user's meal information, calculate nutrition values, identify potential gaps, and generate recommendations. And finally, the Streamlit frontend provides the user-facing interface. For this project, we used the Global Food and Nutrition Database from Kaggle. After pre-processing, it ended up with 37,781 food records, each described by 12 nutritional features, covering both macro and micronutrients. To process and serve this data, we used Python with libraries like Pandas, NumPy, and PyArrow for data handling, scikit-learn and Jobly for machine learning, SQL Alchemy for database integration, Fast API for backend services, and Streamlit for the interactive frontend. Now we talk about the nutritional analysis. So this is one of the main function of NutriSense AI. The first user first selects foods and specifies their quantities. Then the system calculates its relevant nutrient totals. Then these values are compared against the configured nutritional target to generate the nutrition score. The system also checks which nutrients fall below the defined threshold and identify it as a potential deficiency. In this project, we used a random forest regression model. The model learns the relationship between the 12 nutritional features and the health scores provided by the dataset. We trained the random forest using 150 trees with a maximum tree depth of 12 and a minimum of 3 samples per leaf. The dataset was divided into 80% training and 20% testing data. It serves as an additional scoring signal within the recommendation workflow. Now we discuss the model evaluation. So we evaluated the random forest using a both held out test set and five-fold cross validation. On the test set, the model achieved an mean absolute error of 0.014 and root mean square error of 0.228 and an R-square value of 0.999. So this shows that the random forest reproduced the health score much more closely than the simple predicting the average score. And we also compared the model with a simple baseline, which produced an MA of 7680. And in five-fold cross-validation, the model achieved a mean R squared of approximately 1 and with a standard deviation of 0 across all the five folds. Now I'll briefly walk through the code base and explain the role of each major component. The project is organized into separate layers so that the data, application logic, machine learning, backend, and front-end are kept relatively independent. Starting with the app folder, we have four files inside this. The first one is database.py. It manages the SQLite database connection, and models.py defines the database model for full records. Schemas.py defines the request and response structure used by the API, and the main.py is the main fast API application that exposes the backend endpoints. Next, we see the config folder. It contains the shared configuration and constants. So config.py manages project paths and database settings. Nutrition constants contains the nutritional reference values and meal targets, while the recommendation constants contains the parameters used by the recommendation logic. Then we see the services folder. So it contains the main application logic, like food services handles the food searching, nutrition services performs meal level nutritional calculation, recommendation services handles food recommendation and ranking, and meal planner generates a suggested meal plan. And we see the script folder. It contains the supporting data and machine learning pipeline. So the loads the processed food data into the SQLite database, while the train recommendation model trains and evaluates the random forest model and saves the train model. And the trained model is stored into the model folder as recommendation model.joplib, and while the processed food data is stored under the data folder as food feature.parquet, and the SQLite database containing the food records is stored separately under the database folder as nutrition.db. On the front end side, the front end folder contains the Streamlit application. Home.py provides the main dashboard. Utils.py contains shared front-end utilities, and the pages contains the search codes and meal analyzer pages. Finally, requirement.txt contains the Python dependencies required to run the project, while notebooks and docs are included for supporting analysis and documentation. Now I'll move from the implementation to the actual application interface. So first we'll run the API and then we'll start the Streamlit application. Now we'll start the dashboard through Streamlit in another terminal.
So this is our NutriSense AI home dashboard. It provides an overview of the system and acts as the starting point for the application. Now, the first functional page is search foods. Here we can search the food database and retrieve the corresponding nutritional information. Let's check this. So it retrieved 20 food and we can see the related nutrient information. And next, the main workflow is the meal analyzer. Here, user selects the food items, specifies their quantities, and construct a meal. Okay, so let's construct a meal. So we have added two simple food items, and now let's analyze. So we've got score, and it says that we need improvement. And this is the overall nutrition summary. And it detects the deficiencies that we are lacking in nutrient in calcium, iron, and vitamin C. So accordingly, it recommends foods. So it recommended food based on health score and recommended score. And lastly, it suggested a meal plan. So this is the whole application workflow. Now let's go back to our presentation slide.
Okay, so now let's talk about the results. So system successfully connects food search, meal analysis, nutrition scoring, deficiency detection, food recommendation, and meal planning. And one of the challenges was to coordinating the complete application, including pre-processing, data integration, API development, recommendation logic, machine learning training, and front-end development. There are also important limitations. The nutritional targets used by the system are general meal level targets, so they do not represent the requirements of every individual. And also recommendation quality depends on the coverage and quality of the underlying food data set. Now we move to the conclusion and future direction. To conclude, the project achieves its main objective, building an integrated nutrition intelligence workflow. The system takes food and meal data and converts into nutritional insights, find potential nutrient gaps, recommend food and meal plan suggestion. There are several possible directions for future development. These includes personalized nutritional targets, support for dietary restrictions, larger and independently validated datasets, and more advanced recommendation method and real-time deployment. So this brings us to the end of the NutriSense AI project. The source code repository link is provided here for the further exploration. Thank you for watching.